Hello, good day everyone. Here is the solution to the second assessment of chemistry at the Science Hub Academy. So the very first question says that the diagram above represents an atom of. So to estimate that, we just need to understand the number of electrons being spread out within the shells. So the first shell, which is the K shell, has 2 electrons. The second shell has 8 electrons, and the third shell has 2 electrons. So KLM. So to represent that, you are adding 2, 8, 2. Now here, since the atomic number, since the number of electrons is 12, so the number of electrons is definitely equal to the number of protons. So this implies that the proton number is 12. So which of the elements has the proton number of 12? That's magnesium. So the answer here is magnesium. Number 2, which of the following atoms represent deuterium? So deuterium is one of the isotopes of hydrogen and has H12. So looking at that, it has a proton of 1. This is the number of protons, also equal to the atomic number. It has number of electrons of 1, because the number of electrons is equal to the number of protons. Then the number of neutrons will definitely be 2 minus 1, which is also 1. So which of the following actually represents the deuterium? And so the most appropriate answer is proton 1, neutron 1, and electron 1. So that is the first option here. Number 3, the number of electrons in the valence shell of an element of atomic number 14 is. So the atomic number is 14, so the electronic configuration will be 2, 8, 4. So this implies that the valence electron is 4. So that's this. Then number 4, we have which element leads to the measurement of the charge on an electron. So now we have the contribution done by R.A. Millikan. So R.A. Millikan was actually the scientist who discovered the charge on electron using what we call the oil drop experiment. So the measurement of the charge of an electron was done by R.A. Millikan using the oil drop experiment. So here is the option. So the discharge tube experiment was done by J.J. Thomson, and the alpha scattering particles was done by Rutherford. So number 5, question 5 says a hydrogen atom which has lost an electron contains a hydrogen atom H11. Losing an electron, meaning that it is losing 1 electron. As a result, it becomes H+. So having H+ implies that it has lost 1 electron, so the number of protons is still 1. The number of neutrons would be 0, because that would be 1 minus 1, atomic mass number minus number of protons, so that's 0. And then the number of electrons would be 0, because it has lost that 1 electron. So which one is most appropriate here in the options? That's option 1, protons only. Then number 6, here we have to calculate the molecular formula of the compound given the percentage abundance of each of the elements: carbon, hydrogen, and oxygen. So carbon, hydrogen, and oxygen. So carbon is 40, hydrogen is 6.7, and oxygen is 53.3. So we divide by the atomic masses: 12, 1, and 16. So this gives us 12 plus 40 plus 12, that will give us 3.33. So this gives us 6.7, and this also gives us 3.33. So we divide by the smallest number. The smallest number is 3.33 divided by 3.33 divided by 3.33. So this gives us 1, 2, 1. So the empirical formula for that is CH2O. So that's our empirical formula. So to detect the molecular formula, we are going to do the calculation here. Empirical formula multiplied by N equals to the molar mass. The molar mass in question is 180, so equals 180. So what do we do here? CH2 0 into bracket N equals to 180. So let's calculate the value of N. The atomic mass of carbon given was 12, plus the atomic mass of hydrogen is 1 multiplied by 2, that's 2. Oxygen is 16. So let's add everything together, then equals to 180. So 12 plus 2, that's 14. 14 plus 16, that's 30. So we have 30 N equals 180. So the value of N will be 180 divided by 30, and that gives me 6. So let's bring that back into the empirical formula. So that will be CH2, then close the bracket, then you have the 6. So that gives you C6H12O6. So which one corresponds to that? This is actually the answer. Now the next question, that is question 7. Question 7 says rare gases are stable because they... So looking at the option, we know rare gases are actually known as noble gases, and they often have a very stable configuration. So their last configuration is often considered to be 2 or 8. 2 for duplex, and that is majorly found in helium. Helium has a duplet configuration, He, right, which is 2. But for others, they used to have 8 as their valence electron, so that would be octet. So octet configuration, which means 8. So they have 8 or 2 for helium as the stable configuration, or the number of electrons in the valence shell. So which of the following is actually appropriate for that? Rare gases are stable because they have duplet or octet electronic configuration in their outermost shell. So that's most appropriate. So number 8, here we have to calculate the percentage of zinc sulfate, which is heptahydrate. So that is ZnSO4.7H2O. So we have to calculate the percentage of water of crystallization here. So that will be 7H2O over ZnSO4.7H2O multiplied by 100. So let's do that and let's see how that would be. So 7H2O will definitely give us 7 multiplied by 2 times 16, which will give us 7 multiplied by 18. So 18 multiplied by 7 will give us 126 grams. So that's actually the mass of 7H2O. Now let's also calculate the mass of the zinc sulfate heptahydrate. So that will give us ZnSO4. So let's calculate that. That will give us, zinc was given as 65 plus 32 plus 16 times 4. So what would that give us? Let's do the estimation. So this gives us 161 grams. So let's add these together with our ZnO4.7H2O. That will definitely give us 161 plus 126. So what will be the answer there? So let's compute that. So that gives us 287. So now to calculate that of the hydration of water, that's water of crystallization, that would be 126 divided by 287 multiplied by 100. So what's that going to be? So that's definitely going to give us 43.9. So approximately that's 44. So question 8 is that. Now question 9 says which quantum number divides shells into orbit? So when you look at the first one, spin quantum number here, that is our ms, this is plus or minus half. It tells us about the direction of the electrons, if it is clockwise or anti-clockwise. Clockwise is up, anti-clockwise is down. So it really doesn't tell us about the division of the shell into orbitals. The magnetic quantum number tells us about the orientation of the orbital. So what we mean by orientation here, it tells us, for example, our p orbital is divided into 3 different orientations, which are px, py, and pz. So it's like a subdivision of the orbital. So it doesn't tell us about the division of the shell into orbitals. Then the principal quantum number tells us about the energy level or the size of the atom. So it also informs us about possibly the K shell, the L shell, and so on and so forth. So it tells us about the size and the energy level of the atom. While the azimuthal quantum number, that actually tells us about the shape of the orbital. So telling us about the shape tells us if it's going to be s orbital, p orbital, or d orbital, or even an f orbital. and it is like a subdivision of the principal quantum number, that is a subdivision of the shell. So for example, in a shell like L shell can contain s orbital and p orbital, so we can have 2s and we can have 2p. So the subdivision of the shell gives us the orbital, that is emphasized by azimuthal quantum number. So question 10, Millikan's contribution to the development of the atomic theory is the determination of. So just like we said in one of the questions, R.A. Millikan was actually the one who discovered the charge on electron using what we call the well drop experiment. So this implies that he used to detect the charge on the electron. Then question 11, 4 elements W, X, Y and Z. W is 2, so this is a non-metal, is actually helium, right? So helium is a non-metal. Then we have X is 6, atomic number of 6, that's 2, 4. Then we have Y, atomic number of 16, that is 2, 8, 6, also a non-metal. So we can use the valence electron to detect them. So if the valence electron is between 1 and 3, that's a metal, with the exception of hydrogen and helium. So all other elements that fall within these categories are metals. But when the valence electron is between 5 and 7, that's a non-metal. So examples of non-metals here are these X, W, X and Y. These are non-metals. So the only options that is a metal is Z20. So the electronic configuration is 2882. So since the valence electron is 2, so it falls within the metal category. So the option is Z. Now here is question 12. Question 12, we are to calculate the value of M given the relative atomic number to be 16.2. So we continue, we take it this way. RAM equals to M1 alpha 1 plus M2 alpha 2. So the relative atomic mass was 16.2, so that is equal to the value of M1 was given to be 16 multiplied by alpha 1, that's 90%, that's 90 over 100, then plus alpha 2, which is M, multiplied by M2, which is M, multiplied by alpha 2, which is 10 over 100. So this gives us 16 times 0.9, right, plus M times 0.1. So we are going to have 16.2 is equal to 16 times 0.9, and that is 14.4 plus 0.1 M. So let's make that the subject of formula. That gives us this equals to 0.1 M. So what will this give us? So this is going to give us 1.8 is equal to 0.1 M. Therefore, the value of M will be equals to 1.8 over 0.1. So M equals to 18. So 18 is actually the answer for this. So the answer is 18 for number 12. So we also have here number 14. So we are to calculate the percentage of oxygen in aluminum sulfate. So we have in Al2SO4 into bracket 3.2H2O. So what do we do here? We simply need to calculate or estimate that by multiplying the atomic masses together. So we have 27 multiplied by 2 plus sulfur, that is 32 multiplied by 3 plus 16 multiplied by 12, right, because you have 12 atoms of oxygen, then plus 2 into bracket 2 plus 16. So let's sum that all together. So this is going to give us 378. So with that, we can therefore estimate the percentage of oxygen. So let's count the total number of oxygen present in there. So that will be oxygen here is 12, oxygen here is 2, so that will be 14 oxygen. So that will be 14 times 16 over 378 times 100. So let's estimate that. What would that give us? So we are going to have 224 divided by 378 times 100. and that will give us 0.5. That will give us 59.2, approximately 59.25 here. So that's that for number 13. Then you move to number 14. So now, as for question 14, which says the neutral atom of neon with atomic number 10 has the same number of electrons as. So let's look at, for example, O2 positive, atomic number of oxygen is 8. So here oxygen is losing 2 electrons, so the number of electrons now has become 6. So this is going to give us 2,4, right? So that of oxygen, this is 2,4, and that of calcium, which has atomic number of 20, losing 2 electrons, so that will be 18 electrons, so that will be 2,8,8. Then this of potassium, atomic number of 19, so losing 1 electron, that's 18 electrons, 2,8,8. And here we have magnesium losing 2 electrons, magnesium atomic number of 12, losing 2 electrons, that's 10, so that will be 2,8. So which one follows the noble gas of neon electronic configuration? Neon is atomic number 10, which is also 2,8. So the appropriate answer is magnesium, Mg2+. So now as for number 15, so for number 15, you are given the electronic configuration of different elements, like hydrogen was given to be 1s1. So, and then you have nitrogen was given to be 1s2, 2s2, and 2p3, and that of oxygen was given as 1s2, 2s2, and 2p4, and zinc was given as the whole of the stuff, let me use as argon core, then with a 3d10. So we can use the last electron to detect if it's going to be paramagnetic or not. So as for paramagnetic compounds, so always having lone pair of electrons in their valence electron, at least unpaired, they are fully made up of unpaired electrons. For example, if you have P3, which is having 1 electron all through, so it's said to be paramagnetic, right? But if it is in twos, for example, we have it this way: 1 2 2 2, that makes 6. So this is diamagnetic. So looking at it, we get to realize that nitrogen itself will be paramagnetic, and again hydrogen, which has just 1 electron and just singly filled, so this is also paramagnetic. So the option is 1 and 2. Number 16, 2 elements which are, okay, let me clean that. Now 2 elements P and Q with atomic number of 11. So P has atomic number 11, that's 281. Then Q has atomic number of 8, that is 26. So this is going to give us P will lose 1 electron to become positively charged, and Q will gain 2 electrons because it is a non-metal, and then to become octet it becomes Q2 minus. So 1 comes down here, 2 comes down here, that will be P2 Q1. So when you compare it to X and Y, so that means the value of X is 2 and the value of Y is 1. So that's option 2 and 1. Now here we have question 17, pardon. So oxygen is a mixture of 2 isotopes. So we are given the atomic mass of the isotope. M1 was 16, M2 was 18, alpha 1 is 90, and alpha 2 is 10. So how do we estimate RAM, electric atomic mass? That will give us M1 alpha 1 plus M2 alpha 2. So the value of M1 is given as 16 times alpha 1, which is 90 over 100, right? Then plus M2, which is 18, alpha 2, that is 10 over 100. So let's sum them all together. That will be 18 plus 0.1, right? Then plus 18 multiplied by 0.1, plus 16 multiplied by 0.9. So let's multiply them all together. So this will give us 1.8, right, plus 16 multiplied by 0.9, that gives us 14.4. So let's sum them all together. So that is going to give us 16.2. So this implies that the answer to question 17 is 16.2. So that's how to solve that. Now here again we have number 18. So if an element with electronic configuration of these, which is 2, 1s2, 2s2, 2p, this is an error, it should be 2p6, 3s2 and 3p4. so this is actually what we have. So now an alkaline earth metal is always a group 2 metal. So this is not considered a group 2 metal, because when you count all the electrons, this is going to give us 4 plus 6 10, 10 plus 6, that is 16. So 16 is 2, 8, 6, that's a chalcogen. So it's not this. Then s block element is not an s block element because the valence orbital does not fall in the s block. That's not this. Transition element, no, because it does not fall in the d block. Then a p block element, yes, that is going to be appropriate, because this element or this compound has the valence orbital to be a p block element, a p block orbital. So that's that for question 18. Now our question 19, which of the following statement is true when potassium atoms form? So we know potassium atom is potassium ion is K. So when it forms an ion, it loses one electron. Normally it has 19 as the atomic number, which is, then after losing one electron, that will be 18 electrons. So that will be 288. So this implies that it's going to have the achieve the electronic configuration of argon, simply because argon also has atomic number of 18, which gives us 288. So this is the appropriate answer. And finally, number 20. So the line observed in the sample of hydrogen spectrum are due to, now when you have a transition of electron from a lower energy level to a higher energy level, such an electron can therefore come back to its resting position by emitting light in form of spectrum. And so we say this is going to be done by energy. The electron is going to emit energy through transition. So energy by electron transition. So that's what causes emission of spectrum. So the answer is this. So this marks the end of our assessment for the week. We meet again in class for the continuation of our work. Have a nice day. Goodbye.